Okay, picking up where we left off, we're on page 284, talking about network operating systems. And in the old days, you could go get like Banyan Vines or Novell NetWare, and you would install this on your system, and then perhaps you were using like Microsoft or Unix or something else down here in the other systems. Now that's practically gone because almost all operating systems come baked in with networking support. So you buy, Windows Server operating system. It comes with everything you need. You don't need to go out and buy a separate network operating system because you just buy a server version of Windows. So it's just Windows, just with all the stuff baked in. Likewise with Linux and all the rest of the folks. It's all just baked in now. So there's no real issue there. There's a cool term here. They talked about this new feature coming up called software-defined networking. And this is kind of an interesting setup. Instead of having, like I described how you have like a switch and a router connecting to another one, like you have a building that's a 3-story building, and you put maybe you put like a switch on the first floor and a router connected to the second floor, and it connects to the third floor. Okay, those are kind of static, right? Because you've told it exactly how to connect and how to make everything work. But a software-defined network is able to look at the patterns and say, it looks like that there's way too much traffic going on the third floor going to the internet. So let's change the way that the network is configured to give them more bandwidth. So it's dynamically allowing you to make changes on the fly. Kind of cool. And so you'd have to have like a giant system, a server that connected to each one of these networking devices that would tweak them, all right? Because, some sort of a networking system control point that would go in and say, okay, we're going to change the way this router is configured and this one and this one and this one to allow this to happen. Pretty cool. Very rare that you would think you'd find one in business today unless you were like working for Google or something. Okay, let's continue. The next thing we're going to talk about is security. So in the old days, there was an issue of people tapping cables. Like I had a network cable or particularly coax cable. If I had coax cable like going across the parking lot to another building, you could quite literally tap the cable and see all of the traffic going, all of it going through. Now it's not quite that bad because most likely the traffic going across is only the traffic that belongs across the cable. Remember we talked about that, about like difference between a switch and a hub. In the old days, when you had the coaxial cable kind of a set up in a bus scenario, even if you had two machines that were side by side that wanted to talk to each other, it sent it along the entire cable. Everyone could hear the conversation, even though they were side by side. Kind of crazy. Okay, so basically, the technique that everyone uses to secure communication, because they can't prevent it from being tapped, is encryption. So that kind of makes sense. So encryption is just a way to make things unreadable unless you have the particular key, the encryption key. All right. So this is kind of simple. I have a message that says, "Hello, John," and then I encrypt it, and it comes out, question mark A, 8, blah, 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 blah. So yes, I can intercept this message. Yes, I can tap the cable, or I can listen in on the wireless, and I will be able to see what the packet has in it. The problem is I won't be able to tell what that means. So there's software at the other end that decrypts it and then comes back to "Hello, John." So I can't prevent you from tapping my cable or listening in, but I can encrypt. That's the whole point of this. So Wi-Fi, of course, is the big business here. Wi-Fi is broadcast over radios, and anyone with an ultra cheap device can listen in. There's an awful lot of techniques out there. This is wireless protected access 2, WPAS2, is the current standard for doing encryption. If you do not have WPA2 on your wireless device, and by the way, both devices have to work. I mean, if I have an old machine, old tablet or old phone that doesn't do WPA2, then it's going to negotiate with my wireless access point and drop down to a different encryption standard. The old WEP encryption standard could be broken within just seconds. if you were listening in. This one can still be broken. It might take a little bit longer, not much longer. So people sitting at a wireless, let's say you're at a cafe with wireless access, and you're on your tablet sending a message to somebody. Yeah, you've got some level of protection there, but you probably need an additional level, which we'll talk about in just a minute. Okay, war driving. That's all about people who drive around. You can go to these cool websites, and what they've done is located every single wireless access point that they can hear, and whether or not it's open. And so you can go in and, without too much trouble, a hacker can obtain whatever the key is. And all you basically have to do, even if you were using WPA2, if I was out in the parking lot during a business day and there was an awful lot of traffic going on your wireless system, it wouldn't take me very long, probably less than 20 minutes, to have broken the key, and I'd be able to hear every single conversation clear text. Okay. So, by the way, that's the reason why businesses basically don't use wireless much. They might use wireless for like in the conference room, so visitors can come in. But most companies are kind of skittish over using wireless because we're just not there yet. Every time we come up with some sort of encryption technique, they end up breaking it. Okay, cool. The next thing we're going to talk about is the way you actually get there, and you get there through a thing called a virtual private network, a VPN. And what this does another set of encryption on top of whatever other encryption you have going on. So now I'm sitting at my internet cafe, and I want to send an email. What I do is I create another type of encryption between my machine, and this is what's called typically it's going to be a point-to-point encryption. So it's going to be an encryption between my machine and the server I'm talking to. So I have the WPA2 encryption going on and a VPN encryption going on, and that is pretty doggone secure. There's very little people that have the wherewithal of breaking this, unless you had 30 or 40 years to break the key. So it's pretty doggone cool. And these can get really sophisticated. All right, let's say, for example, let's forget about wireless. Let's say, for example, that you're at home and you want to connect to your corporate network. Okay. What you would do is you would connect to the internet, right? So your machine has to connect to the internet, and then it goes to the other servers at the other end. Which means anybody who's along the way in the internet can tap that cable and see what's going on, right? So I need a way of encrypting that. So VPN is that technique. So all the work at home people, the people who do telecommunicating, use VPN. Now there's software-based VPN where you install a client thing. Like I have CISK VPN client installed on my machine, and it negotiates a key that I don't even know. I don't see the key, and so it does some magic, and presto changeo, I have a secure connection between these 2 points. If you really want to get nuts, they have this hardware-based stuff where these keys last like 30 seconds. When you're establishing a key, it's going to prompt you to enter this number, and so you enter that number, and you better be quick, and you hit the button, and it'll grant you access, and presto changeo. The military grade ones have matching chips, where they come in a locked box with 2 chips in it, and you take one chip and you put it in this one device, and you stick it on your corporate LAN. You take the second chip, and you stick it in this device, and you take this device home, and the two are paired together. And that's how the encryption key takes place. No one knows what the encryption key is because it's all inside the hardware. Okay, so a VPN is typically called like a tunnel. It tunnels through the internet. That's a fairly descriptive term. What they're talking about is I'm making a connection between the 2 points, and I'm encrypting everything. So even if you tapped in or listened in or whatever, you'd still be able to see the packets. You just wouldn't know what they meant. Okay, let's continue. The next thing I talk about is telecommunications services, and some of this is pretty dumb. I'm not going to talk about cellular phone service. I mean, come on, guys. They're little cells, right? So it's designed for the coolest part about cell phone service is it's designed to hand off. As I'm driving down the road, I'm in cell number 1, And as I approach the edge of cell number 2, it's going to just hand off that conversation. You'll never hear it. There's no crack in the phone or anything. It just automatically hands off the signal to the next guy. Okay, that's about the only thing interesting. I'm going to move on. The next thing to talk about is small cell. I've heard this called femtocell. Ooh, isn't that a cool term? So femtocell is all about these itty-bitty cell phone repeaters. I mentioned to you before that I worked in a metal building, and our cell phone service in the building was horrible. And what we did is we bought a cell phone repeater, okay? Basically, a miniature cell tower, all right? Except what we did is we climbed up on the roof, put a little antenna stuck out. It wasn't a very big antenna. Stuck an antenna out, ran a cable down to the middle of the building and plugged in this device, and all it did was it took the cell phone signal coming in and just rebroadcast it. That's what cell phone services do. So it was just a miniature cell phone tower. Now, admittedly, it cost like $200. It wasn't very expensive, and the range was probably about the same as Wi-Fi. Maybe 100 feet, maybe. So we bought a cell phone tower and put it inside our building, and then inside our building we had fantastic cell phone service inside the building. Okay, that's what that's all about. Let's move on. Digital subscriber line, DSL. So this is a type of service that you can get like in your home. There's two different types of DSL. They have asymmetric DSL, which is the most common. And the way this works is my download speed is going to be faster than my upload speed. Just think about it from a perspective of the internet, right? Like I click, type in, kumquat and hit return. And so the word kumquat gets sent, right? And that's what, 30 bytes? And then I get an entire Wikipedia page on kumquat, which is a huge amount. So historically, the amount of data that I send to the internet is incredibly small. So the outgoing pipe doesn't need to be that big. The downcoming pipe needs to be huge. And so that's what asymmetrical DSL is all about. Now, if you're a gamer, well, you probably want the speeds to be a little bit better because I'm trying to attack some character in a game, and I want that upload speed to be pretty doggone fast. So a lot of people don't like the asymmetric capability. If all you're doing is surfing the web, asymmetric is fantastic. If you're trying to host a web page on, let's say you were one of those crazy people that decided to put a web page on your own machine. So at home you have a web server, a real honest-to-God web server. Okay, now think about this for just a minute. People coming to you, sending a message to you, right, is coming down the pipe, right? That's your download speed, right? But when they send the response back, when your website sending on your machine at your house is sending the message back to them, it's going through your upload speed. And if your upload speed is really, really slow, then that whole web page is going to be horribly slow. It's like the smaller of the two. Whatever the smaller of the two is what the performance of your web page would be. So you can't host services at your house with a asymmetric kind of a scenario. Okay, let's move on. The next thing they talk about is voicemail. I don't even know why this is in here, talking about voicemail. Okay. Yeah, it exists. Mail to services, reverse 911 using GPS technology and things like that. Okay, whatever. Moving on. All right. Now we talk about home devices, which is kind of cool. We're going to talk about the things you would have to set up in your home to be able to make this work. But doggone it, we're pretty doggone close to the 15-minute mark. So we'll pick this thing up again in just a few.